Hello everyone. Here we are going to see Block 5, Unit 19. PERT means Program Evaluation Review Technique. Structure of this unit is objectives, introduction, assumption for PERT, solved examples, sum up, keywords, and terminal questions. First objective of this unit. After reading this unit, students should be able to understand the importance of PERT, to locate the critical path, to determine the project completion time, and to find out the probability of completion of a project before a stipulated time. Next, we are going to see the introduction of PERT. PERT is nothing but Program Evaluation and Review Technique. It is a tool that would help a project manager in project planning and control. It would enable him in continuously monitoring a project and taking corrective measures wherever necessary. This technique involves many statistical tools. So this technique, unlike CPM, takes into account the uncertainty of project duration into account. Yes, PERT calculations depend upon some time estimates, three time estimates. It depends upon three time estimates. Then assumption for PERT. Assumption for PERT. In CPM, the assumption is that precise time estimate is available for each activity in a project. However, one finds most of the times that this is not practically possible. Whereas in PERT, we assume that it is not possible to have precise time estimate for each activity, and instead probabilistic estimates of time alone responsible. A multiple time estimate approach is followed here. In probabilistic time estimate, the following three estimates are possible: optimistic time estimate, pessimistic time estimate, and most likely time estimate. Two main assumptions made in PERT calculations are: first thing, the activity durations are independent. Activity durations are independent. That is, the time required to complete an activity will have no bearing on the completion times of any other activities of the project. And the second most important assumptions made in PERT calculations are: the activity durations follow beta distribution, where beta distribution is nothing but a probability distribution with density function. With density function. So here we are going to see the definitions for three time estimates, that is optimistic time estimate, pessimistic time estimate, and most likely time estimate. Optimistic time estimate, it is denoted by T naught, and it is defined as the duration of any activity when everything goes on very well during the project. That is, labors are available and come in time, machines are working properly, money is available whenever needed, there is no scarcity of some material needed, etc. Then pessimistic time estimate, it is denoted by TP and it is otherwise known as greatest time estimate. It is defined as the duration of any activity when almost everything goes against our will and lot of difficulties is faced while doing a project. Next thing is most likely time estimate. It is denoted by TM and it is defined as the duration of any activity when sometimes things going on very well, sometimes things going on very bad while doing the project. The three estimates of time have the relationship T naught less than or equal to Tm less than or equal to Tp. In practically, neither the pessimistic nor the optimistic estimate may hold in reality, and it is the most likely time estimate that is expected to prevail in almost all cases. Therefore, it is preferable to give more weight to most likely time estimate. Therefore, a weight value for most likely time estimate is 4 and a weight of 1 each to pessimistic and optimistic time estimates. Then we have formula that the weighted average of these three time estimates are, it is denoted by TE and it is calculated by using the formula T naught plus 4Tm plus TP divided by 6. Since we have taken 6 units, 1 for TP, 4 for TM and 1 for T naught, we divide the sum by 6. With this time estimate, we can determine the project completion time as applicable for CPM, that is critical path method. Since PERT involves the average of 3 estimates of time for each activity, this method is very practical and the results from PERT will have a reasonable amount of reliability. Then measures of certainty. Measures of certainty. The three estimates of time are such that T naught less than or equal to Tm less than or equal to Tp. Therefore, the range for the time estimates is the difference between the pessimistic and optimistic values. The time taken by an activity in a project network follows a distribution with a standard deviation of 1/6 of the range. Yes, the standard deviation is denoted by sigma and it is calculated by using the formula Tp minus T naught divided by 6, and the variance, it is denoted by sigma square and it is calculated by using the formula Tp minus T naught divided by 6 the square. The certainty of time estimates of an activity can be analyzed with the help of the variance. Next, you are going to see solved examples. Problem 1. Two experts A and B examined an activity and arrived at the following time estimates. Yes, we have to determine which expert is more certain both his estimates of time. So here we are going to find the variance values for two experts A and B. For that, first we are going to write the variance formula. Variance is denoted by sigma square. So sigma square is equivalent to Tp minus T naught divided by 6 the square. For expert A, variance is equivalent to TP value for expert A is 8 and T naught value for expert A is T naught. So 8 minus T naught divided by 6 the square. It is 4 by 6. 4 by 6. Yes. For expert B, the variance is equal to TP value for expert B is 10 and T naught value for expert B is 4. So 10 minus 4 divided by 6 the square. 10 minus 4 is 6. 6 divided by 6 is 1. 1 square 1. So the variance is less in case of A. In case of expert A, variance value is very less compared to in expert B. Hence, it is concluded that expert A is more certain both in estimates of time. Then problem number 2, find out the time required to complete the following project and the critical activities. For that, they have given activity and predecessor activity for activities and 3 estimate values for activities. Using these values, we are going to find critical path and critical activities. For that, first we are going to find the time estimate for each activity by using these 3 time estimate values. These 3 time estimate values. For that, we going to obtain the table first. The table first. Yes, in the table, first column denotes activity column and second column denotes the predecessor, value predecessor activities for activity, and the third column denotes optimistic time estimate values in days, and the fourth column denotes most likely time estimate values, and the last column denotes pessimistic time estimate value in days. So using this, we are going to obtain the table. In the table, first column denotes the activity column and the second column denotes optimistic time estimate values. These 2 column values are there in the table, and the third column denotes most likely estimate values are divided by 4. Why? Because means for time estimate, formula for time estimate is T naught plus 4 times of Tm plus Tp divided by 6. For that, we have to multiple most likely time estimate values by 4. Then the next column denotes pessimistic time estimate values. These values remains the same thing, and the next column denotes addition value for T naught and for Tm and Tp. Then the last column denotes the time estimate values for each activity. Okay, so see here, T naught is 2 and 4 times of Tm is 16. 16 plus 2, 18, and the pessimistic time estimate value for activity A is 6. So 18 plus 6 is 24. Likewise, we have to find all these things. Then the time estimate value is calculated by divided by 6, that is 24 divided by 6, it is 4. 36 divided by 6 is 6. 60 by 6 is 10. 72 by 6 is 12. Likewise, we have to calculate. Using the single time estimates of the activities, we get the following network diagram for the project. Yes, we are going to draw a project network. So, for activity A, it has no predecessor activity, and we have to draw a path between 1 and 2, node 1 to 2. its activity name is A and its time duration value is 4. Then 2 to 3. 2 to 3. Draw a path between a node 2 to node 3. Its activity name is B and its time duration value is 6. Then 2 to 4 is there. 2 to 4 is there. Why? Because means C has the predecessor activity A. C has the predecessor activity A and its time duration value is 10. Then D. D has the predecessor value B. So we have to draw a path between 3 and 5. 3 and 5. Its corresponding time duration value is 12. 12. Then E has the predecessor activity C and its corresponding time duration value is 9. And F has the predecessor value D and its corresponding time duration value is 21. 21. 21. Then G has the predecessor value F. G has the predecessor value F and its corresponding time duration value is 22. 22. And final node is 8 and it has the predecessor activities H and I and its corresponding time duration values are 5 and 3. 5 and 3. So it is a project network diagram. Project network diagram. So consider the parts beginning with the start node and stopping with the end node. There are 4 such parts for the given project. They are 1 to 2, 2 to 3, 3 to 5, 5 to 6, 6 to 8. It is the first path. And the second path is 1, 2, 4, 5, 7, 8. It is the second path. Likewise, we have to find all the possible paths beginning with the start node and stopping with the end node. So path 1, it is 1 to 2, 2 to 3, 3 to 5, 5 to 6 and 6 to 8. 1 to 2 has an activity A and its corresponding time duration value is 4. And 2 to 3 has an activity B and its corresponding time duration is 6. And 3 to 5 has an activity D and it has the time duration value 12. And 5 to 6 has an activity F and its corresponding time duration value is 21. And 6 to 8 has an activity H and it has its corresponding time duration value is 5. So the time for this path 1 is 4 plus 6 plus 12 plus 21 plus 5. It is 48 days. So for path 2, it also starts from the starting node 1 and ends with the stopping node 8. So 1 to 2 has an activity A and its corresponding time duration is 4. And 2 to 4 has an activity C and its corresponding time duration is 10. And 4 to 5 has an activity E and its corresponding time duration is 9. And 5 to 6 has an activity G and its corresponding time duration is 6, and 6 to 8 has an activity I and its corresponding time duration is 3. So we have to find the path, the time for the path 2. That is 4 plus 6 plus 12 plus 6 plus 3. It is 31 days. 31 days. Then path 3, it starts from the starting node 1 and stops with the ending node 8. So 1 to 2 has an activity A and its corresponding time duration value is 4, and 2 to 4 has an activity C and its corresponding time duration is 10. Then 4 to 5 has an activity E and its corresponding time duration is 9. Then 5 to 6 has an activity F and its corresponding time duration is 21. Then 6 to 8 has an activity H and its corresponding time duration is 5. So time for this path, time value for this path is 4 plus 10 plus 9 plus 21 plus 5. It is 49 days. 49 days. Then path 4. It starts from the starting node 1 and ends with the ending node 8. Okay. Then 1 to 2 has an activity A and its corresponding time duration value is 4, and 2 to 4 has an activity C, its time duration is 10, and 4 to 5 has an activity E and its corresponding time duration is 9, and 5 to 6 has an activity G and its corresponding time duration is 6, and 5 to 8 has an activity I and its corresponding time duration is 3. So time for path 4 is 4 plus 10 plus 9 plus 6 plus 3. It is 32 days. 32 days. So we have to compare these time values for 4 parts. Why? Because means critical path. Definition for critical path is the longest time duration value. The longest time duration value. For that, we are going to compare the time values for all the 4 parts. Therefore, maximum of 48, 31, 49 and 32. It is 49. It is 49. We see that path 3 has the maximum value, maximum time value. So, maximum of 48, 31, 49 and 32 is 49. So we see that path 3 has the maximum time. Therefore, the critical path is 1 to 2, 2 to 4, 4 to 5, 5 to 6, 6 to 8. And the critical activities are A, C, E, F and H. And the non-critical activities are the rest of the activities values, that is B, D, G and I. Therefore, project time, also called length of the project. Project time is also called the length of the project. It is 49 days. 49 days. Yes. Next problem. Find out the time variance and standard deviation of the project with following time estimates in weeks. In weeks. For that, first column denotes the activity column, second column denotes optimistic time estimates for activities, and the third column denotes most likely estimate, that is TM values for the corresponding activities, and the last column denotes the pessimistic time estimate values for the activities. So here we are going to find the standard deviation and variance for the project network. So first we are going to frame a table. Obtain the table. In that table, first column denotes the activity column, second column denotes the optimistic time estimate values for the activities, and next column denotes most likely time estimate values, and that values are multiplied by 4. Why? Because means time duration value is denoted by te. In that formula, most likely, that is 4 tm is there in that formula. So we have to multiply the most likely time estimate values by 4, and the next column denotes the pessimistic time estimate values. That values are there in the table, and that values remains the same thing. Then the next column denotes the addition of these three time estimates values, that is t naught plus 4 times of tm plus tp, and in the last column you are going to calculate time estimate, that is te, by using this formula, that is t naught plus 4 tm plus tp divided by 6. Okay, so see here, activity 1 to 2 is having the optimistic time estimate value is 3, and 4 times of most likely time estimate is 4, and pessimistic time estimate value is 9, and the addition of these three time estimate value is 36, that is 3 plus 24 plus 9, it is 36, and this 36 is divided by 6, it is the value for time estimate te 6. Likewise we are going to calculate all the activities values, all the activities time estimate values. Yes, then draw a project network diagram by using the time duration values. So draw a path between 1 and 2. Its time duration value is 6, and its activity name is A. And path between 2 and 3. Draw a path between 2 and 3. Its activity name is C, and its time duration value is 12. And draw a path between 2 and 4. Its time estimate value is 5, and draw a path between 3 and 5. Its activity name is F, and its time duration value is 11, and draw a path between 1 and 5. Its duration value is 9, and draw a path between 6 and 7. Its time duration value is 15, and we have to draw a path between 7 and 8. Its time duration value is 15. So consider the parts beginning with the start node and stopping with the end node. There are three such parts for the given project. They are path 1. Path 1. It starts from the starting node and ends with the end node 8. Yes. So 1 to 2, 2 to 3, 3 to 5, 5 to 8. 1 to 2 is having an activity A, and its time duration is 6. And 2 to 3 is having an activity C, and its time duration is 12. 3 to 5 is having an activity F, and its time duration is 11. And 5 to 8 is having an activity 1, and its time duration is 4. So time for the path 6 plus 12 plus 11 plus 4, it is 33 weeks. 33 weeks. Then path 2. Path 2. It starts from the start node 1 and ends with the ending node 8. So 1 to 2 is having an activity A and its time duration is 6. 2 to 3 is having an activity D and its time duration is 5. 3 to 5 is having an activity C and its time duration is 7. And 5 to 4 is having an activity I and its time duration is 4. So time for this path 2 is 6 plus 5 plus 7 plus 4. It is 22 weeks. Then path 3 1 to 6 is having an activity 5 and its time duration is 5. It's having an activity B, and 6 to 7 is having an activity E and its time duration is 9, and 7 to 8 is having an activity H and its time duration is 15. The time for path 3 is 5 plus 9 plus 15. It is 29 weeks. Then we are going to find the critical path, and the definition for critical path is the longest time duration value. For that, we are going to find the maximum of 32, 22, and 29. It is 33. It is 33. It is noticed that the path 1 has the maximum time. Therefore, the critical path is 1 to 2, 2 to 3, 3 to 5, and 5 to 8. Then the critical activities are A, C, F, and I. And the non-critical activities are B, D, G, and H. Therefore, the project time is 33 weeks. The project time is 33 weeks. And now we are going to calculate the standard deviation and variance for the critical activities. Yes. So the critical activities are A, C, F, and I. And critical activity for activity 1 to 2 node is there, and its optimistic time estimate value is 3 and pessimistic time estimate value is no most likely time estimate value is 6, and its a pessimistic time estimate value is 9. So range is calculated by using the formula, the difference between TP and T naught. TP and T naught. So 9 minus 3 is 6. And standard deviation is denoted by sigma, and it is calculated by using the formula TP minus T naught divided by 6. It is 1. And variance for the activity A, that is 1 to 2, is TP minus T naught divided by 6 the square. Yes, it is 1 the square is 1. For activity 6, range value is 12. For activity C, that is 2 to 3, range value is 12 and standard deviation is 2 and variance value is 4. For activity F, that is 3 to 5, range value is 6 and standard deviation is 1. Also, variance value is also 1. For critical activity I, that is 5 to 8, range is 4, standard deviation 2 by 3, and variance value is 4 by 9. Yes, variance of project time, also called variance of the length of the project. It is sum of the variances for the critical activities, that is 1 plus 4 plus 1 plus 4 by 9. It is 58 by 9 weeks. And standard deviation of project time, which is equivalent to square root of variance value. Therefore, square root of 58 by 9, it is 2.54 weeks. 2.54 weeks. Then problem number 4, a project consists of 7 activities with the following time estimates. Find the probability that the project will be completed in 30 weeks or less. For that, they have given activity and predecessor activity and optimistic time estimate values, most likely time estimate values, and pessimistic time estimate values. For this problem, first we are going to find the time estimate by using this formula. TE is equivalent to T naught plus 4 TM plus TP divided by 6. So with the single time estimates of the activities, we are going to draw a network diagram. For that, this is what the network diagram for the given project. So consider the parts beginning with the start node and stopping with the end node. There are 3 such parts for the given project. Path 1 starts with the start node 1 and ends with the ending node 6. So 1 to 2 has an activity A and its corresponding time duration value is 5. 2 to 3 has an activity B and its corresponding time duration value is 3. 3 to 5 has an activity E and its time duration value is 6. 5 to 6 has an activity G and its time duration value is 8. Then path time for this path is 5 plus 3 plus 6 plus 8. It is 22 weeks. Then path 2, it starts from the starting node 1 and 1 to 2 is having an activity A and its time duration is 5. 2 to 4 is having an activity C and time duration is 8. 4 to 5 having an activity E and its time duration is 7, and 5 to 6 having an activity G and its time duration is 8. So time for this path 2 is 5 plus 8 plus 7 plus 8. It is 28 weeks. Then path 3. It starts from the starting node 1 and it has an activity A and its corresponding time duration is 5. Then 2 to 5 is there. Its activity is D and time duration for this node is 4. And 5 to 6 is there. It has an activity G and its corresponding time duration value is 8. So time for this path 3 is 5 plus 4 plus 8. It is 17 weeks. So now we are going to find the critical path for this project network. For that, critical path is defined as the longest time duration value. For that, we are going to compare the times for 3 parts. The time values for 3 parts. So maximum of 22, 28, 17 is 28. It is noticed that path 2 has the maximum time and the critical path for path 2 is 1 to 2, 2 to 4, 4 to 5, 5 to 6. The critical activities are A, C, F, and G. The non-critical activities are B, D, and E. B, D, and E. Likewise, we are going to find the project time. It is 28 weeks. So now we are going to find the standard deviation value and variance for critical values. Standard deviation and variance formula is TP minus T naught divided by 6 the square. So standard deviation for the critical path is root 2. It is 1.14 and Therefore, 92 percentage chance that the project will be completed before 30 weeks. In other words, the chance that it will be delayed beyond 30 weeks is 8 percentage by using it is determined by using the normal distribution. And next one is, let's sum up. In this unit, students able to understand the time estimate technique and how to solve the problem using three estimate values, and some keywords has been given for you: pessimistic, optimistic, most likely time estimates, and some terminal questions have been given for you. We'll see you in the next class. Thank you.